Good evening, everyone. So, people still are so today we'll be looking at the fourth week of Data Science for Engineers course, and first I'll be starting with the theory, little bit of the theory portion, and then I'll be moving on to the assignments. So, this week you had learned several topics starting with the optimization. Okay, so optimization problem, first we look at what it is. So it consists of maximizing or minimizing a real function by systematically choosing input value from within as allowed and then computing the value of the function. Okay, so that is what is usually happening for an optimization problem. So the use of a specific method to determine the best solution is often called as the optimization problem or optimization technique. Now when you see the first graph, it represents, in the terms of ML algorithms, it represents a regression problem where you will fit a line for the different set of points which are given. So it is like, for that set of problems, it is like you have to find a best line that can represent the data which is given to you. In the case of the next diagram, the second diagram, it is like a best line to classify the data, because you can see a set of blue points here and set of red points here, and these two lines represent, so this line will represent a place where, or a plane that we have studied last week, that best separates the data. Okay, so this kind of problems are known as classification problems. Now univariate optimization problem means like it varies with one particular variable, so that means like minimization of a function, objective function f of x, with respect to certain constraints and a decision variable. So you can see in this graph, this is the function of f of x, and this function has a global maximum and a global minimum. It also has a local maximum and a local minimum. Okay, now univariate optimization conditions, you have learned this. So if your function is minimize f of x for x belongs to R, then the necessary condition for x to be a minimizer is f dash of x equal to 0, and you will be finding the points from that where the condition happens. And then the sufficient condition is like the second derivative, or f double dash of x, should be greater than 0, which tends to note that the function you are speaking about is minimization. Then sometimes in the questions you might get to maximization problem also. In that case you have to check like f double dash of x should be less than 0. So the minima or maxima of f of x exist when, so the minima exists when f dash of x equal to 0. Minima or maxima exists when the first derivative according to the necessary condition f dash of x equal to 0, that is the answer. Then the maxima of f of x exists when f double dash of x is less than 0. This is like a simple question based on the theory. Now the next one, we'll move on to a question, simple question only. So the similar kind we will be seeing in the assignment questions also. So we have been given like, it have been given like f of x equals to x raised to 4 by 4. You can also do with me, x raised to 4 by 4 minus x cube by 3 minus x square. So in this case first you have to find f dash of x and have to substitute equal to 0. That means f dash of x means 4x cube by 4 minus 3x square by 3 minus 2x, that you have to substitute it to 0. That means you will get x cube minus x square minus 2x equal to 0. So this you can write like x into x square minus, wait a moment please, okay, so x into x square minus x minus 2 equal to 0. So solving for this, you can get x equal to 0 or x equal to, what have you got here for this one? You can solve and tell the answer. I'll give you a minute. You can put in the chat window. So people have put 0, minus 1 and 2 and minimum value at, okay, yeah, so 0, minus 1 and 2 if you put okay, 0, minus 1 and 2, then what you have to do is you have to, so these are the stationary points, okay, these are the stationary points, and then you have to, so my board is causing some problems today. Minus 2, these are stationary points. Okay, then what we have to do is find the values of x at which minima exist and this value. So already Sridhar have put x equal to 2. Are all of you getting that answer? So it's like first you have to find out double dash of x. That means it is 3x square minus 2x minus 2. So this you have to find at the stationary point. So at f double dash of 0 you will be getting minus 2. Then f double dash of minus 1 you will be getting 3 plus 2 minus 2, so equal to 3. Then f double dash of 2 you will be getting 12 minus 4 minus 2, that means 6. Okay, so if f double dash of x is greater than 0, there exists the minimum values, but here you can see that there are 2 points here, 2 points are present, so where the it's greater than 0, so we have to try it. F double dash of minus 1 and f double dash of 2 gave greater than 0. So what we have to do is first we have to see like f of 1 we have to check. Okay, so f of 1 will be giving like 1 by 4 minus 1 by 3 minus 1. Okay, so this value comes around, I think it's like minus 2.667. Then the other one is like f of so next one is like f of, so this is f of minus 1, right? So it will come like 1 by 4 plus 1 by 3 minus 1, like that. So f of 2 will come around minus 5 by 12, that is minus 0.416. Okay, so here it is minus, sorry, I have made a mistake. The first one will be coming, f of minus 1 will be coming like minus 0.416, and f of 2 will be coming like minus 2.667. That's why one of you have given the value as minimum value at x equal to 2. Okay, so that is the answer. Now, of all the rectangles of area 100, which has the smallest perimeter? Okay, so this I have already given the answer. Let L be the length and B be the breadth of the rectangle. So if these two both, if we are assigning these two values as L and B, then area can be given as length into breadth, that means L into B, and perimeter can be given by 2L plus 2B. Then here the optimization function, so what is asked? Which has the smallest perimeter. So the optimization function is the perimeter, and the decision variable is length. Okay, we can take it as length. So f of L we can give like 2 into L plus 2 into B. So since we have taken the decision variable as length, we will take it as A by B equal to A by L. So you will get 2L plus 2 into A by L. So you will get in this form. And then after that, so okay, so then after that what you can do is you can apply the first order condition. So this is your function, then applying first order condition will give you 2 minus 200 by L square, that is equal to 0. Solving the above equation, you will be getting the stationary points, which are plus 10 and minus 10. Then you know that length cannot be negative, so you are taking only the plus 10 value. So in that way you will be getting the breadth also as 10. Then perimeter you can find like 2 into 10 plus 2 into 10, you will get the answer as 40. I think this is very clear. Then next one, a manufacturer determines the daily average of producing Q units is determined by the number of units produced per day, which minimize the average cost. So our objective is to minimize the average cost. Okay, so cost is given by C of Q equal to 0.001 Q square, 3 zeros, okay, minus 0.08 Q plus 65 plus 5000 by Q. So here the optimization function is C of Q, and Q is the decision variable. Okay, so in this way we are writing this equation. Then first order condition we are applying. So then we will get C dash of Q equal to 0.002 Q minus 0.08 minus 5000 by Q square. Then we have to solve this equation. Solving it, meaning like equating it to 0, will give you the answer of Q as 500. Then again we will solve it and we'll find the second order condition, and C double dash of Q equal to this one you will get. We'll put this value into this equation and it will give a positive value, that means it's the minimum value. Hence the manufacturing cost can be minimized by producing Q is equal to 500 units. Okay, now multivariate optimization. So till now we looked at univariate optimization. That means there was one function or objective function, and we have to minimize or maximize it in some other cases. And then we have only one variable. We had only one variable. Now we are moving to cases where you might have to use some set of variables which will influence the function. So it's like z equal to f of x1, x2, etc. up to xn, and one of the examples that can be shown is like z equal to root of x1 square plus x2 square. This example you have seen in the lecture videos, and how the contour of that plot looks like also you have seen. So we'll go through that. Then z equal to f of x1, x2, etc. up to xn, that is the multivariate optimization function. Then the necessary condition for x to be the minimizer is this one, gradient of f of x, grad of f, should be equal to 0. If you do that, that means like dou f by dou x1, dou f by dou x2, etc. up to dou f by dou xn, that should be equal to 0, and you will be getting the values. Then the sufficient condition is like del square f of x has to be positive definite. That means that it's also known as the Hessian matrix. So how to find that out is written here, like the diagonals will be written like dou square f by dou x1 square, dou square f by dou x2 square, and dou square f by dou xn square. Then depending on the row and column, it will be looking like dou square f by dou x1 into dou x2, then dou square f by dou x1 into dou x3, like that till dou xn. Okay, so this is the Hessian matrix. So when you get a multivariate optimization condition, these are the two functions that you have to look at. Okay, then so we'll move on to a multivariate optimization problem. So find the first and second order necessary condition for the function and tell whether the minima exists or not. So the function is f of x1 x2 equal to x1 plus 2x2 plus 4x1 square minus x1 x2 plus 2x2 square. So since this is an example problem, I have given the answer also. Applying the first order necessary condition, del f equal to, or gradient of f equal to 0. That means this is treated as dou f. Okay, so dou f by dou x1, dou f by dou x2 equal to 1 plus 8x1 minus x2, 2 minus x1 plus 4x2 equal to 0 and 0. Then you will get x1 x2 values as minus 0.19 and minus 0.53. Then the second order necessary condition, that means this should be positive definite. So del square f equal to dou square f by dou x1 square, dou square f by dou x1 x2, dou square f by dou x1 x2, dou square f by dou x2 square. You will be getting these values. So one of the ways by which you can find out whether your matrix is positive definite is to find out the eigenvalues of the del square matrix, and if they are both greater than 0, then it means that your Hessian matrix is positive definite. Okay, so if it is positive definite, then you can say that the minima exist as at the critical points. Okay, we'll see other cases also. Then at the fourth lecture, you have seen the gradient descent method, which is applicable to find the minima of the given function, and it's usually seen in neural networks and all, where it is usually applied in the backpropagation algorithm to find the parameter. So it's like the steps for doing that is like at the step 1, the iteration start at x of k, and then you will see the search direction sk, which is negative of gradient of f of x. Then that means minus del of f. Then the new point will be written as xk plus 1 equal to xk plus alpha k into sk, where alpha k is the step size, or in neural network terms it is known as the learning rate. Okay, now the gradient descent illustration is given there for the parameter p and the cos function given. Okay, this is just a figure meaning like first if your learning parameter is very small, then it will be taking a long time to reach the next point, and it's like it will be taking short steps. That means your function, solving your function will take a long time. Then if it's a very big learning parameter, then it will take huge steps. It will shorten the time, but your answer might not be accurate. Then label data and model output the fit and line with according to that. So just these are some figures. Now find the values of minima found after 3 iteration for function for f of x given as f of x equal to x1 square minus 2x1 x2 plus 2x1 with constant step size of 0.5 and initial value 0 0. So the function given like x1 square minus 2x1 x2 plus 2x2 plus 2x1. So find gradient first. That means 2x1 minus 2x2 plus 2, and dou f by dou x1, sorry, dou f by dou x2 will give you minus 2x1 plus 4x2. Then you can take the initial values as 0 0, which is given, and step size alpha equal to 0.5. So x1, which is the next value, can be given by x0 plus alpha into s0. That means x0 minus alpha into del f, means s0 is negative gradient of del f, right? So negative gradient of f, right? So 0 0 minus 0.05. Then del f we have already found out. We'll put that initial condition here, and then we will find the next value. Then at the next iteration we will take this first point, which is minus 1 0, and then we will put it here. Also in the gradient also we will put those values, and we will get the second value. Then we'll look at the third iteration, which has x2 plus alpha s square s2. That means x2 minus alpha into del f. It will give you the answer. So 3 iterations are shown here, and we will get the final answer after 3 iteration as minus 2 minus 1. So that's the values of minima. Okay, now so these are some of the examples for this week's problems, and I have kept 2 links also where you can learn more about these values, this Hessian matrix, and how to find out whether it is positive definite or semi-definite or not. Okay, so you can go through these links later. Next I will go to the assignment questions. So here we will see the assignments of the previous run course. So just wait a moment. So I think the figure is visible. Okay, so the PPT is visible, I think. Yeah. So okay, we will start with the questions. The first question, is it clear? Yeah. The first question is f of x equal to x cube plus 3x square minus 24x plus 7. You can also solve along with me. Okay, so we will see what is the answer for this one. So it is written like f of x equals to, okay, x cube plus 3x square minus 24x plus 7. Okay, so first we have to, what are the questions given? Maximum or minimum or maximum value or stationary points. All options are present, so we'll have to find the whole set. Okay, so first necessary condition, f dash of x equal to 0, that we will apply. So f dash of x means 3x square plus 6x minus 24, we are substituting it equal to 0. That means you can simplify it as x square plus 2x minus 8 equal to 0. Solving for this, you will get x values as equal to x equal to 2 and minus 4, I think. Okay, so these are the points that you are getting, stationary points that you are getting. So 2 and minus 4 is the answer, so you can discard this option. Okay, then the next one, you have to find where the minimum and maximum value is lying. So first what you can do is like find the double dash of x. Okay, double derivative, so that you will get it as 2x plus 2. So answer B, one person is giving. Okay, that we will see 2x plus 2, then is f double dash of x. No, it doesn't have to be equated to 0, sorry. So f double dash of x equal to 2x plus 2, and we will put these values. F double dash of 2, you will be getting it like 6, and f double dash of minus 4, you will be getting like minus 6. Okay, so wherever it's greater than 0, here in this case it is greater than 0, in this case this is less than 0. So in at x equal to 2, we will have a minimum point, and at x equal to minus 4, we will have a maximum point. Okay, so here the question is minimum or maximum. So x equal to 2 will give you the minimum for x of x. That answer B is fine, that is right. Next, another thing that we have to look at, there is another option, maximum value. So this is wrong actually. Option A is wrong, option D is wrong, B is right. Then what we have to do is find the maximum value. So f of 2 you have to find. Okay, f of 2 equal to 8 plus 12 minus 48 plus 7 you will be getting. Okay, so at the end you will be getting it, sorry, okay, so actually the maximum value you have to find, sorry, I'm sorry, not the minimum value. So you got like, you will get the minimum value at x equal to 2, and the option C is like you have to find the maximum value. Okay, so maximum value is at point x equal to minus 4, so you have to find out f of minus 4. Okay, so minus 4 meaning like minus 4 whole cube plus 3 into minus 4 whole square minus 24 into minus 4 plus 7. That means like this is will be minus 64, then this will be 48, and this will be 96 plus 7. Think you'll be getting the answer around, so this will be plus. Okay, this will be plus, so you will be getting the answer 87. Am I right? Yeah, so the answer for these questions are B and C. Okay, for this question the answer is B and C. Everyone okay with this question? If everyone's okay, I'll move on to the next question. Yeah, so find the gradient of f of x equal to x square y at x, so x comma y equal to 1 comma 3. So this also is the same pattern. So first, this is like two variables have come, so like bivariate you can tell, it's multivariate optimization. So first you have to find, so it's written like del of f. So first anyway you have to find the gradient. So del of f equal to, it's like a matrix, right? Dou f by dou x, dou f by dou y. So yeah, answers are coming up anyway. So it will be like x square y, so dou x square y by dou x will give 2xy, and dou f by, sorry, here it's dou f by dou y, so dou f by dou y will give x square, okay, and del f at 1 comma 3 you have to find, so that will be 6 and 1. So the answer is B. Tarun, how have you got A? It's dou f by dou x first, okay, and then dou f by dou y, since the function is named as f of x comma y. So first you have to write for dou f by dou x and dou f by dou y then, okay Tarun? Yeah. Then find the Hessian matrix for f of xy equal to x square y at xy equal to 1, 3. So the same question is repeated, and then you have to find the Hessian for that. So already you have del f equal to here 2xy and x square. This we have seen last slide, okay. Now you have to find out the del square of f. So that is written like, here it is like dou square f by Sridhar, you have raised a hand. Any questions? So this is like the Hessian matrix, okay. So first you have to find out dou square f by dou x square, okay. So already dou square f by dou x is this one, right? So 2xy, again with respect to x you will get 2y, then dou f by dou x, again with respect to y you will get 2x, the same will be repeated here, and then dou square f by dou y square you will be getting like 0, okay. Then what you have to find? The Hessian. So everyone is giving the answer C, yeah. So you have to find the Hessian at 1 comma 3. That means you will get y value is 2 into 3 will be coming here, then 2, 2 and 0, which will give you the option C, okay. Now let f of xy equal to minus 3x square minus 6xy minus 6y square, the point 0, 0 is a what kind of a point you have to find out, okay. So we'll start solving this one. So this is like you have two variables, right? So you have to find del f first, okay. That means you will get, you have to find dou f by dou x and dou f by dou y. So it will give you, okay, so it will give you minus 6x, okay, minus 6y, and here it will give you minus 6x minus 12y. So this is the gradient that you will be getting. Then you have to find, so you can substitute equal to 0 and you will get what is the point at that particular place, okay. Or you can find it like okay, you can find the points like that. So not needed right now. First we are asked to find out whether the point is a saddle point, maxima or minima, okay. So we'll go with the Hessian matrix also. So it will be like, earlier I have written dou square x by dou square f by dou x square, okay. So it will be minus 6 here, then dou square so next one will be dou square f by dou y of dou by dou y of dou square f by dou f by dou x. That means you will be getting here minus 6, then here also the same thing will be repeating minus 6, and again dou f by dou y again differentiated with respect to y will give you minus 12 here. So this is the Hessian. Okay, just want to find out what is the eigenvalues for the Hessian matrix, then only we can find out which is it, like whether it is a maxima or a minima or a saddle point, right? So for that we have to find the eigenvalues. Okay, so the eigenvalues will give you, so you have to find out determinant of a minus lambda I equal to 0, that you have to find out. That means that minus 6 minus lambda, minus 6 and minus 6, and minus 12 minus lambda, determinant of these equal to 0. I am getting answers as A and C. Okay, we will see that. Okay, so I am getting it like minus of 6 plus lambda I can write, and into minus of 12 plus lambda minus 36 equal to 0. Solving for this, I'll be getting like lambda square plus 18 lambda plus 72 plus 72 minus 36, right? So anyway it will be like lambda square plus 18 lambda plus 36 equal to 0. I'll be getting the values when I solve these. I'll be getting like lambda 1 equal to minus 2.29 and lambda 2 equal to minus 15.70. I think you are getting this answer. If you are not, just inform me. So here the eigenvalues are negative, right? Okay, so people have given A saddle point and C minima. So eigenvalues are negative. It will mean that what kind of a point will be obtained? Anyway, if you give it equal to 0 also, you can be getting like x equal to y. So yeah, so eigenvalues are negative means you will be getting maximum. Okay, so here the case is like eigenvalues are negative. Okay, so negative implies that the particular point is a maxima. Okay, so answer will be B. If your answer was, if it was like eigenvalues are positive, then it will imply that it is a minimum point. Okay, now if eigenvalues are mix of positive and negative, this is one of the ways, okay, to find out whether your matrix is like that. Okay, so Pratap, you have written minimum. Okay, yeah, understood. So it's like if it's a mix of positive and negative values, then it's a saddle point. So answer here right now is maxima. Okay, yes, I hope that's clear for everyone. Okay, so next one, it's a theory question. In the optimization problem, the function that we want to optimize is called, everyone can answer. Yeah, objective function. The optimization problem, minimum of f of x can also be written as maximum of f of x, is true or false? Can it be written? minimization of f of x can also be, can it be written? I mean, this is a pretty straightforward question only. Will any time minimization and maximization problem will be same? Okay, yeah, it will be false. You can't write minimum as maximum. Okay, so answer is false. Gradient descent algorithm converges to the local minimum. Is it true or false? Yes, yeah. So answer is true. Now we'll move on to assignment questions of Jan 2023. Okay, till now were the assignment questions for last case. So some of the questions again is coming in the Jan session, so I'll be repeating some of the questions which have come. Okay, so here f of x is given as x cube plus 6x square plus minus 3x minus 5. You can start answering the question. Okay, so here f of x is given as x cube plus 6x square minus 3x minus 5. Okay, so the question is like, it's actually a connected question. Okay, the next problem also will be there, so you can find out what are the answers. So it will be like they are asked for the maximum, they are asked for the minimum, the stationary points, all these have been asked. So first we'll be doing the f dash of x. Okay, since it's a univariate optimization problem, so we'll be getting 3x square plus 12x minus 3. Substituting it equal to 0, you will be getting the answer for x like, so it will be like x, you can write this as x square plus 4x minus 1 equal to 0 also you can write. So x equal to it will be minus 4 plus or minus, if you write like that, or you can solve in the calculator and tell me. Okay, A and B, one person is putting. Okay, we will see. Yeah, so x values you are getting like minus 2 plus or minus root 5. Okay, that means minus 2 plus root 5 and minus 2 minus root 5. These are two values. Then now we will find the maximum minimum value. So f double dash of x will be giving like 2x plus 4. You can write like that. Sorry, you can write it at the beginning portion itself. It will be like 6x plus 12. Okay, so f double dash of x at x1, so I'll name this as x1 and this as x2. Okay, so at x1 it will be like 6 into minus 2 plus root 5 plus 12. Okay, answer will be 6 root 5, and f double dash of x at x2 will be 6 into 2 sorry, it is like minus 2 is there. Okay, minus 2, so minus 2 minus root 5 plus 12, that will give the answer as minus 6 root 5. So this is greater than 0, which will imply the minimum value, and this is less than 0, which will imply the maximum value. So at minus 2 plus root 5 you will get the so some have given like the answer A and B. Why? Minus 2 plus root 5 will give the minimum. This is right, B is right, A is wrong. Okay, yeah, so many other people are writing. Okay, so the stationary points for f of x is minus 2 plus root 5 and minus 2 minus root 5. That's also right. So B and C are the answer. B and C. So these are the answers. Now use the following information to answer question 2 and question 3. Okay. So the question is maximization of f of x. F of x is given as x raised to 4 plus 7x cube plus 5x square minus 17x plus 3. Okay. So here first thing is like second order sufficient condition for, so x star is written as the maximizer. Okay, earlier we had seen minimization, so this one is maximization. One has put the answer as A, so yeah, so this is like A, B, C, D. Okay, some other are putting as D. Okay, okay, we will see. Okay, so first is like second order sufficient condition, so we have to go up till f double dash, right? So f dash of x, if you write, it will be 4x cube plus 21x square plus 10x minus 17. Okay, that solving that, f dash of x equal to 0 will give you the values of x like 0.662. you can solve this and get the answer. Okay, points minus 4.48 and minus 1.43 you will be getting. Okay, then f double dash of x we will find, so we will get this as 12x square plus 42x plus 10. Now we will put the values in stationary points which we have got in this equation. So if you put 0.662, it will be like 12 into 0.662 whole square plus 42 into point. So one other person has given answer D. Okay, so we will see how it comes. So this first one is coming like 43. Okay, similarly if you put f double dash of minus 4.48, I think you will be getting the answer as minus 419. you can check that. Then 5 double dash of minus 1.43 will be giving like minus 74.59. okay, so these are the values you'll be getting. So it's like asked maximizer of f of x, so this one is greater than 0, which will point to the minimization problem. These two are less than 0. Okay, so it will point to the maximization problem. Now what you have to see is that, so second order sufficient condition, right now we have got 12x square plus 42x plus 10. okay, that itself we have got right now, so D is okay. Just remember that these are the conditions that you are obtaining, because the second question is like, okay, so this one, if less than 0, it will point to the maximum, so maximization condition is obtained as D. That is okay. Now in the next question you have to find the value of x star. Okay, meaning like x star be the maximizer of f of x, so you want to find out where the maximizer lies. So for that what I'll do is like, so right now we have got two values, meaning like at minus 4.48 and minus 1.43 you are getting the maximum values. Now you want to find which are the or you want to find out x star. That is the thing. Okay, so for that what I'll be doing is like, I'll first find minus f of minus 4.48, that I'll be finding. So it will look like minus 4.48 raised to 4, I'm substituting it in the f of x equation. Okay, plus 7 into minus 4.48 cube plus 5 into minus 4.48 square minus 17 into minus 4.48 plus 3. So just find out the answer. So can take a moment. So similarly you can find out the answer. Okay, so similarly you have to find out for f of minus 1.43, and there you'll be getting like, you have to calculate this also, plus 7 into minus 1.43 cube plus 5 into minus 1.43 square minus 17 into minus 1.43 plus 3. You have to find this also. So here when you solve it, you can solve it later. You will be getting minus 47.07, and this one is 21.24. okay, so among these the maximum value is this one, right? This is the maximum value among these 2 points where we have found out that there is a maximum value. So you can say that x star, or the maximum value, lies at minus 1.43. So in this question the answer will be C. So you can check these answer once more. You can take a moment for that. Okay, so first was to find out what was the second order sufficient condition. So first order condition we substituted it to 0 and we got these points for x value. Then we found out the second order condition, sufficient condition, and we got it like this one. So for it to be a maximizer of f of x, the second order condition, sufficient condition, should be like, I'll just write, maximization means the second order condition should be less than 0. So that's why we have put this one less than 0. Okay, so that is the second order condition. Then just we found out the values for the double derivative at the stationary points that we have found out. So minus 6.662 gave 43, minus 4.48 gave minus 419, and minus 1.43 gave minus 74.59. So if you look at this, at 0.662 the minimum value can be obtained, since the since the sufficient condition will be coming like greater than 0, which means that is for a maximizer of that function f of x, and the minimization, it will be a minimization of function of f of x, and the maximization happens when it is less than 0. The second order condition is less than 0. Two of those conditions are coming up. 2 points are giving less than 0. That's why what we'll have to find is like, we have to put those points in the main f of x function, and then f of that particular point will give you, first one gives you minus 47.07, and f of minus 1.43 gives 21.24. So comparing these two values, you can find that 21.24 is greater than minus 47.07. So 21.24 is the maximum value. And which value is giving that maximum value? X star value of minus 1.43 is giving that value. That's why you can go with this answer for X star. Okay, I hope that's clear. Any doubts you can ask. Have anyone raised your hand, or I can't see anything in the chat window, so I hope it's clear. Okay. Sridhar, you have any questions? You are raising your hand. Okay, anyway, so we'll move on to the next question. F of x equal to 2 sin x ranges between 0 to 2 pi. Find the correct options. So for this one, what we'll do is like we'll just plot the graph. Okay, so f of x is given like this. Okay, just I'll plot for 0, pi by 2, pi, 3 pi by 2 and 2 pi. Okay, so it's given like 2 sin x, so values varies between plus 2 and minus 2. Okay, so the sine graph usually looks like starts from 0, reaches maximum at pi by 2, and then again 0, then it reaches the negative maximum, and then again 0 at 2 pi. Okay, so this is like plus 2 and this is minus 2. This is the 0 value. Okay, so just you don't have to go through any specific function here. Looking at this one itself, you can see that at pi by 2 it is the global maximum of f of x anyway, because this will be like oscillating in between these two values only. 2 sin x means it will be oscillating between plus 2 and minus 2 values only. And you know that since we have not been given any other angle values. Okay, we have just been given with pi by 2, pi, 3 pi by 2 and 3 pi by 2, like that only it's given. So looking at this graph, you can find out that the maximum value, or you can say the global maximum itself, will happen at pi by 2. So this is one of the answer. Okay, and then now the global minimum will lie at 3 pi by 2. So 3 pi by 2 is the global minimum for f of x. So answer will be A and D. Pi by 2 is the global maximum of f of x, and 3 pi by 2 is the global minimum of f of x. Okay. Yes, so now again a connected question is coming. So it's given like f of x equal to 2x1 square. So I'll start writing that. You can also solve along with me. So 2x1 square plus 3x1 x2 plus 3x2 square plus x1 plus 3x2. Okay, so first you have to find out the gradient for f of x. Okay, so that is like the necessary condition. So gradient of f of x, that means you have to find out dou f by dou x1 and dou f by dou x2. This will be like in a matrix. Okay, so directly you can tell the answer, right? So dou f by dou x1 will give you 4x1 plus 3x2 plus 1, and this one will be given like 3x1 plus 6x2 plus 3. Okay, so 4x1, 3x2, 1, 3x1, 6x2, 3. So answer will be A. Everyone has found that answer, so that's okay. Next one is next question. So connected question, just remember the answer. Find the stationary point for f of x. Okay, so it's like you have found out, just I'll rewrite this here again. Del of f you had just now found out like 4x1 plus 3x2 plus 1 and 3x1 plus 6x2 plus 3. This is the del f that you have found out. Okay, now you have to find out the stationary point. So what you can do is you have to substitute dou f by dou x1 equal to 0, and another one is dou f by dou x2 equal to 0. Okay, so substituting both of them, you will be getting two equations, 4x1 plus 3x2 plus 1 equal to 0, and 3x1 plus 6x2 plus 3 equal to 0. You can solve for these two equations and tell me the answer for x1 and x2. You can use your calculator and tell me the answer. Okay, I'm getting the answers as C. Okay, that's right. So I'll be getting the answer as 0.2 and minus 0.6. Okay, so the accepted answers are 0.2 and minus 0.6. Now again, this is another connected question. You have to find the Hessian matrix. Okay, so for the Hessian matrix you have to have the del f first, right? So you have the f of x. Now you have got the del f like 4x1 plus 3x2 plus 1 and 3x1 plus 6x2 plus 3. You have to find the Hessian, which is given like dou square f by dou x1 square, dou square f by dou x1 dou x2. Same repeated here, dou square f by dou x1 dou x2. I think I'm getting some answers. Dou square f by dou x2 whole square. So this is the matrix that you have to find. Okay, so I'll be getting, so dou square f by dou x1 square, I'll be getting 4. Dou square f by dou x1 x2 I'll be getting 3 and again 3, and dou square f by dou x2 square, I'll be getting 6. Okay, so the answer is 4336. Answer C. Yeah, most of you have got that answer, 4336. Now the stationary point obtained in question 6 is A. So we have got these points. Just looking at this, we have got stationary points as 0.2 and minus 0.6. Now we have got 4336, right? So we have to find out whether it is like a minimum or a maximum or a saddle point. So just what you have to do is find out the eigen values. So 4336 is our del square f, or the Hessian matrix. I'll denote like this, 4336. Find out the eigen values. So it's like 4 minus lambda 3 and 6 minus lambda. Determinant of that, substitute equal to 0. You will get 4 minus lambda into 6 minus lambda minus 9 equal to 0. So solving for this one, the answer will be coming like, so this will be coming like 24 minus 10 lambda plus lambda square minus 9 equal to 0. So the answer, you have to solve for lambda square minus 10 lambda plus 15 equal to 0. Find the values of lambda. So I think you can get lambda 1 equal to 8.16 and lambda 2 equal to 1.84. Both these values are greater than 0. Okay, implying that, okay, I'm getting the answers as B. Okay, so implying that it is a minimum point. Okay, minimum point. So the answer is B. Okay, you are getting a minima at your stationary point. Okay, now let f of x1 comma x2 equal to 4x1 square, just 4x1 square minus 4x1 x2 plus 2x2 square. Select the correct options. I think you can solve this from with the help of the earlier problem. So it's like del f first you have to find out. So this will be, first in case of x1 you will be getting like 8x1 minus 4x2, and then this one will be minus 4x1 plus 4x2. Okay, anyway, so just you have to find out the stationary points first. Okay, yes, so another thing, so you can find out which is the stationary point. If you get like 2x1 minus 4x2 equal to 0, and minus 4x1 plus 4x2 equal to 0. Okay, if you solve that, what answers you will be getting? Getting B. Okay, so that's right, 0 0 is a stationary point. 0 0 is a stationary point for f of x. Just go to the del square also, del square f, that will be coming like, with respect to x1 it will be 8, and with respect to x2 it will be coming minus 4 and minus 4 and then 4. Okay, just find out the determinant a minus lambda I equal to 0. Okay, and you'll be getting it like 8 minus lambda minus 4 minus 4 and 4 minus lambda. K. Gayatri Devi, ma'am, why have you raised your hand?
Yes, ma'am, I have a doubt, ma'am.
Yes,
When you solve this above two equations, 8x1 minus 4x2,
yes,
that will give rise to a condition 2x1 is equal to x2.
yes,
And for the second one, it will give rise to x1 is equal to x2.
yes.
How did you reach this solution, ma'am? 0, comma 0?
Um, that we will see. Yeah, that is happening. So in this case what you have to do is like that points are also coming. Okay,
Okay, ma'am.
yeah, so here you are right in that, like this will be 8x1 plus 4 equal to 4x2, that is coming. Yeah, that is true only, and the other one is coming like x1 x2 equal to 0. So those points are also coming. So but this one, then it will be coming like x1 equal to, have I written it right? 8x1 equal to 4x2, right? So x1 will be x2 by 2, right?
Yes, ma'am.
Yeah, so in case if x1 equal to 2, then x2 will be 2x1, that will be 4. So this is also an answer.
Okay.
Yeah. Okay, so that's why I'll come to that. Then the next one is like next one, what you,
Hello, ma'am.
yeah, tell me.
Ma'am, point 24 is not solving the second equation.
Yeah, I'll come to that. Yeah, yeah, so the next one, the del square, I am getting like what will be coming, yeah, So this one equal to 0, 8 minus lambda and 4 minus lambda plus minus 16 equal to 0. So can you tell me what answer you are getting here? Lambda values? You can solve and tell me the answer. Okay, lambda values. You can put in the chat window also. Are you getting like anywhere around 10.47 and 1.527? I hope you are getting that. Lambda values. Yeah, okay. So right now actually we got this value. What is that? Yeah. So here we got it as positive. I think one of you is unmuted. Okay, so you have got this like positive definite. Okay, meaning since like the eigenvalues were greater than 0, that implies a minimum function. Okay, yes. So okay, so you can give like the Hessian matrix is positive definite. That also is true. Now again you can come to the initial position and then put the values for f of x1 x2. Okay, then in the first case if you are putting 0 0, okay, this for 0 comma 0 you will be getting 0 value. Okay, again for f of x1 comma x2 at, for example, you can look at 2 4 and you will be getting like 16 minus 32 plus 32, you will be getting like 16. So among these values, which is the minimum? This is the minimum value. This will be kind of the, you can say like the maximum value. Okay, so our current thing is like the Hessian matrix is positive definite. This actually you can't say. Okay, but still this one, looking at these two, this is the minimum value in this case. Okay, and you have got your matrix like positive definite, so you can tell that your point is 0 0. Okay, so in that case, that's why, yeah, that's why this particular case we haven't taken. Okay, I hope that's clear.
Ma'am, for stationary point, it should be minimum. The condition satisfied should be minimum.
Stationary point, actually here the question was like a minimization problem, okay? It's not
Okay.
specified, but since you are getting your Hessian matrix as a positive definite, it means
Okay.
that it should be the stationary point should be pointing to a minimum value. Stationary
Yes, ma'am.
points means you can get either minimum or maximum value, anything can be possible. But
Yes, ma'am.
here at the end, the Hessian is giving you like a positive definite matrix. So it
Okay.
points you to a minimum value. So you have to find out where the minimum value is coming.
Yes, ma'am. Thank you.
Yeah, okay. So the accepted answer is 0, 0. You can find out like the stationary point. Okay. Just if you are getting like the question like just like that, you are asked what is the stationary point and no other options are coming regarding the Hessian matrix, then you can give the two answers also. Okay. Now in the gradient descent algorithm, the step size should be same for each iteration. Is it a true or a false statement? You can put the answers in the chat window. I'll name this as B A and this as B. Okay, so yes, everyone's putting the answer as B. So it's like the step size, it's not always same for each iteration. In gradient descent it can change. Okay, now some extra questions. Okay, so I think these are most of the models that is available in week 4 of your course. Okay, we'll just see some more models. So it's like the next one is f of x equal to 3x raised to 4 minus 2x cube minus 3x square plus 6. Okay, so this one, you can start solving that. First order necessary condition is first asked, right? So it's immediately you can solve and write it like, okay, I am getting like answers as B. Yeah, so it's like directly you can write for 12x cube minus 6x square minus 6x equal to 0. So this is the answer. Then the same thing I have written here, differentiating with respect to x, you got the equation answer as B. Now same question, f of x equal to this one, which of the following points is or are the stationary points. Okay, so you got this as 12x cube minus 6x square minus 6x equal to 0. You have to solve for this equation, 12x cube minus 6x square plus 6x equal to 0. Solve for this and find, sorry, this is not plus, this is minus, I think. Yeah, solve for this and tell me the answer. So you're putting B and C as the answer. So x equal to any other answer. So because it's x cube, right? Any other answer you'll get. So you can tell like x equal to 0, that is fine, because I mean if you get like x into x square minus x minus 1 equal to 0, solving for this you can get x equal to 0. Then another thing which you can, if you will solve that, you will get 1 and minus 1 by 2. Am I right? So B and C is an answer. This also is an answer. Minus 1 by 2 is also an answer. Is it okay with everyone? I hope it's okay. So moving on to the next one. Same question, okay. So same question, the stationary points which will maximize the value of f of x is asked. So you got the stationary points as 0, 1 and minus 1 by 2, okay. So then you have to now find out where are the maximum points lie. So for that you have to find out the double derivative. So f double dash of x will be given by, just wait a moment. So okay, as f double dash of x will be given by, okay, it will be coming like 36x square. Rishabh Mishra, you have raised a hand. Any doubts? Okay, yeah. Anyway, stationary point which will maximize the value of f of x, right? So f double dash of x, you are getting like 36x square minus 12x minus 6, okay. So at the stationary points you have to try now. So f of 0, you got stationary points as 0, 1 and minus 1 by 2, right? So f of 0 will be giving you minus 6, sorry, f double dash of 0 will be giving you minus 6, f double dash of minus 1 by 2 will be giving you, it will be like 36 into 1 by 4 minus 12 into minus 1 by 2 minus 6, it will be, okay, so this will be plus 6 minus 6, it will be coming like 9, and f double dash of 1 you will be getting like 36 minus 12 minus 6, you will be getting 18, I think. So now you have to find the maximum value. So here you are getting, so for local maximum, f double dash of x should be less than 0 for maximum, okay. So here this one, this particular thing will give you maximum, like, so you can give like at x equal to 0, okay. So answer B. One person I think has given the answer as B. So next question, okay, so you have already seen where the maximum comes up. Next question is stationary point which will minimize the value, okay. So for that, let me rewrite the things. So you got f dash of 0, f double dash of 0 you got minus 6, f double dash of 1 you got 9, sorry, f double dash of 1 you got 18, and f double dash of minus 1 by 2 you got 9. So these 2 points are places where there will be a minimization, okay. Now since you have 2 points, what you have to do is you have to substitute this in f of x. So f of 1 equal to 3 minus 2 minus 3 plus 6. So the answer for f of 1 will be okay. So just the question, so just I am writing that, it's not required also. So this one will be coming like 4, and f of minus 1 by 2 is coming like 3 into minus 1 by, so it will be like coming like 1 by 16, minus 2. So answer, someone has put A. Okay, so the stationary points are asked. Okay, the stationary points which will minimize the values. So just I am writing, it's not required also, just I am writing the answer. Minus 3 into minus 1 by 2 the whole square plus 6. You can find out the answer. So for this question, it's just ask the stationary points which will minimize the values. So it can be, yeah, A and C. So I have given the answer also. Now the next question is, find the minima of the function f of x equal to x minus 5 the whole square minus 5 using gradient search method starting from x equal to minus 6 and learning rate alpha equal to 0.5, and choose the correct statement from the options given below. Okay, so this is a different question. Similar one we have seen in the theory part. Okay, so for this one I will start writing like f of x equal, given as x minus 5 whole square minus 5. Okay, now for this one you can maybe solve this and write. So it's like x square minus 10x plus 25 minus 5. It will be coming like x square minus 10x plus 20. This will be f of x. Okay, now using gradient search method starting from x equal to minus 6. Earlier we had 2 variable function, now it's like 1 variable function only, univariate. So starting function is x0 equal to minus 6, right, and learning rate is given as 0.5. so your next value will be x1 equal to x0 plus alpha into f dash of x, right? So you have to find out f dash of x also. F dash of x equal to, earlier in the theory part we were looking at a bivariate optimization problem. So in that case we had to find out the del of f. Now since this one is a univariate, just you have to find out the first derivative. So it's like 2x minus 10 will be coming. So here what you have to do is like x0 is minus 6 plus alpha is equal to 0.5 into x0, f dash of x at x0 will be required. So 2 into x0 is minus 6 minus 10. Okay, so this will be minus 6 plus 0.5 into minus 12 minus 10 minus 22 will be coming. The answer will be, so the answer will be coming like, it will be coming like 11. Okay, so answer will be coming like 5. Now the next one, so we are asked to find out the minimum of f of x and maximum, minimum, everything is written, right? So f of x1 you can find out. Okay, find the minimum of the function we are asked. So x1 and x2 also we will find. Okay, so x2 will be coming like x1 plus alpha into f dash of x1, right? So this will be coming like 5 is the x1 plus alpha is 0.5 into f dash of x1, that means 2 into 5 minus 10, right? So it will be coming like 5 plus 0, answer is 5. Okay, so it's like all iterations. So first iteration gave you the value as 5, second iteration gave you the value as again 5. Okay, so you can say that the minimum value from this, you can say that the minimum value is 5. Okay, so in this you can write x minimum equal to 5. and with that x minimum you can find f of x min. So f of x min will give you the minimum value required. So 5 minus 5 minus 5 whole square minus 5 will give you the answer as minus 5. Okay, so the minimum is, you have got the answer as A. Okay, the minimum is f of x as minus 5. Any other answers? X equal to 5 leads the minimum of the function. That also is a true answer. A as well as D. A, B, C, D. A as well as D are the answers. Any doubt with this question? X1 equal to minus 17. Yes, ma'am. What is your question?
Ma'am, actually, I have doubt, ma'am, not with regard to this question.
Okay.
Ma'am, in gradient descent, will it not converge to the global minimum, ma'am?
Not necessarily. It can
Okay.
sometimes come to the local minimum also.
Okay.
Yeah.
So the chance of converging to the global minimum is less.
Less, yeah. That's
Okay.
why you later will go to in other machine learning and deep learning models. You won't be stopping with just gradient descent. There is other problems also you can later study, but that's why you are just going for other optimization methods like stochastic gradient descent, then or other.
Gradient descent with
Yeah,
momentum. Okay, ma'am.
yeah,
Okay. Thank you.
like that many things you will be going. Okay.
Yes, yes, ma'am.
Yeah.
Thank you.
So I hope this question is fine. Okay. Yeah, so this answer x1 is equal to minus 17, that I'm still not sure why you have given it like that. You can unmute your mic and tell. Minus 6 minus, okay, I have written it like that. Just wait a moment. Oh, sorry. So this is like, just I have made a mistake here. Okay. Yeah, I think it's like x minus alpha f of x, right? F dash of x, right? I have made a mistake here. Now it will come, okay? Here also I will check. Anyway, this is 0. Yeah. The equation was like x1, the next value will be x0 minus learning rate into f dash of x. Yeah. Yeah, okay. Yeah. So f of x, this is the same question. Answer also I have given. Okay. So this is another question. The gross domestic product GODP of a country in $1 billion following a crisis at t equal to 0 is given by g of t equal to minus 0.16 t cube plus 3.244 t square plus 9.179. Okay. When is the GDP highest? That is just asked. So we have to find the highest GDP. You can solve for this question. So g of t is given as this one, GDP. Now you can find the first derivative. So first derivative will be giving you like minus 0.196 into 3 t square plus 3.244 into 2 t and plus 0. Okay, then so you will be getting this answer as okay, this one and this one. So you'll be getting the answer like minus 0.588 t square plus 6.488 t. Okay, now substituting it equal to g dash of t equal to 0, I mean you'll be getting like t equal to 0, one answer, and t equal to 11.03. You can just check it if you're getting this answer. Then g double dash of t, anyway you have to find out the highest GDP, right? That means maximize GDP. So the problem is like maximize GDP. Okay, so we can find the double derivative. Okay, the double derivative will look like minus 0.588 into 2t plus 6.488. okay, so what we'll do is like first we'll find out g double dash of 0. Let it be in this form itself, because if 0 comes, the double dash value will be coming like 6.488, that is greater than 0, right? It will be meaning like it will be one of the minimum points. Okay, we'll leave that. And double dash of 11.03 we will find out, so that will be like so 0.588 into 2 will be giving, sorry, wait a moment, 0.588 into 2 will be giving around, this one is like minus 1.176 t plus 6.488. okay, so what you can do is this 1.176 into 11.03 plus 6.488. okay, I think you are getting the value as 6.48. just check that once. So it's like 6.488 minus 1.176 into 11.03. you will be getting the answer as minus 6.48. so this is less than 0, which will mean that this is the at x equal to 11.03, the GDP is maximum. That means the answer will be B. okay, now so next thing is like a function. okay, I think I'll come to that question. Okay, I'll come to that question. There is a small problem in that anyway, and just wait a moment. okay, yeah, Vaishali, I think is this coming as the present assignment? Anyway, we'll come to that. okay, so this particular question is coming like just wait till I solve this one. okay, so 7x square plus 10x plus 70x plus 12, find the value as the stationary point. So answer I'm getting like D. okay, I mean if it's like f dash of x equals to 14x plus 70, x equal to minus 5, that is true. Now just oh, I think I haven't included that. Okay, anyway, just what I can tell you is that since it's the present assignment, okay, just I will take blank. Okay, it's not blank. Anyway, okay, we will solve this at the end. Class of optimization problem with no constraints are known as I can give you A, B, yeah, unconstrained optimization problem. Partially I'll explain. Optimum for a function f of x at x star exists if A. Now when the feasibility function regions defined by equality constraints and inequality constraints and are compared, are they the same, or the region defined by the inequality constraint is greater, or region defined by equality constraint is greater usually? Answer, I am getting B. Okay. Okay, so this one is like region given by the inequality constraint is greater. Okay, this one I think you can solve yourself. First order necessary condition will be 48. Looking at the equation itself, it will be 48x cubed minus 6x square plus 18x equal to 0. Okay. Now the restrictions on the possible values of the solution to the optimization problem are called C. I am getting, okay, equality and inequality constraint. Okay, now going to your question, f of x. Okay, just what I'll give here, extra question. Okay, yeah, so f of x is given like x cube minus 12x minus 5. Okay, so here if you solve that, if I think you might have solved it, right? You might be getting the value as x equal to just I'll start the solution, like it will be coming like 3x square minus 12, I think, and if I am solving it, I am getting the value, I'll be getting the value as minus plus or minus 2, right? Okay, so one way you can look at this one is like, so you are given the interval, right? Minus 2 plus 2 to infinity minus infinity minus 2 and minus 2 minus 2. Okay, so first anyway you can follow the usual methods. You can find the double dash of x also. So double derivative will be coming like 6x, and anyway your points are plus 2 and minus 2, so f dash of double dash of 2 is coming like it'll be coming like 12, and f double dash of minus 2 will be coming like minus 12. Okay, I think others also might have solved this, right? Anyway, okay, since so anyway, just look at this. Okay, this will be like, in usual cases you will be telling like this will be the usually you'll be telling like this will be the minimum and this will be the maximum point, right? Okay, but there is one problem here. There is like one term missing there. Okay, so there can be more options. Okay, so first what you can do is just find out some other points. Anyway, you got it like this. It's a varying function, so you are given the intervals like minus 2 to infinity, then minus infinity, minus 2 and minus 2 and 2. Okay, so you can find out some problems. Yeah, sorry, this is repeating. Okay, so 2 infinity, minus 2, minus infinity, minus 2 and minus 2 2. So in this case actually you can't tell it like that. Okay, you can't specifically say like it's increasing, it's decreasing, like that. It's difficult to say, but anyway what you can do is in between take some points. Okay, for example between 2 and 5 you can take one point like f double dash of 5. Okay, like that you can take. So another method, like anyway from this one you got like that, so find out for f of 2 you can find out what is f of 2. So f of 2 might be coming like 8 minus 24 minus 5 will be like minus 21. F of minus 2, if you do, it will be minus 8 plus 24 minus 5, so it will be coming like 11. Okay, you will be thinking like this is the minimum value and this is the maximum value, but this is like a question which is little problematic. Okay, so anyway in the range 2 to infinity just take the value f of 5. Okay, just find out the value. So f of 5 will be giving you like, if you look at this one, if double dash if you are seeing, it will be coming like 30, which is greater than like 0, which will point you to a minimum value. Okay, so f of 2 is minimum, f of 5 is minimum. Okay, just find out the value of f of 5 at that region. Okay, f of 5 I think you will be getting like contrary, like 125 minus 60 minus 5, you will be getting like a high value. Okay, around 60. So if you just look at this like this, at 2 you got the value minus 21, at minus 2 you got the value 11. Okay, at 5 you got the value like around 60, and anyways find out some more values like f of minus 5 maybe you can find, and what is the value you are getting, and then you find out the range. Okay, so you will be getting I think minus 2 you can kind of find out and tell, or you can just check for this point also, f of 0 also you can find. F of 0 will be coming like minus 5, so from that you can kind of say like it is decreasing in the interval minus 2 2, that option can come. Okay, but the other options there is a problem anyway that you can put in the discussion forum also. Okay, and one way you can do is find out some intermediate values in between and then find out the value. Is it okay, Vaishali? Okay, yeah, So since this is a present assignment, anyway you give the answers. Think 2 answers will be coming. Okay, 2 correct answers will be there. So another question, I think I have put a question for solving in R also. So this is like, first we will find out the problem definition. So it's like the company wants to maximize the profit of 2 products, A and B. Okay, so it can be written like 2 products are there, A and B. Okay, which are sold at 25 and 20 respectively, 25 and $20 respectively. And so I can write it as like the price, 25 and $20 are the price. Okay, so I'll just define like product A, I am producing Y1 units, and product B, I am producing Y2 units. Then I am told like I should maximize the profit. So the profit is to be maximized, right? Profit should be maximized. So that means like you can tell like maximization of the sales. Okay, so that means that number of units produced into 25, that means number of 25 means product A, that means 25 into Y1 plus 20 into Y2. We should be selling the number of product A and product B such that this particular function is maximized. So this is a maximization problem, and the objective function will be coming like maximization of sales equal to maximum of 25 Y1 plus 20 Y2. Okay, so we have defined the function. Now, so here when Y1 and Y2 will be called the decision variables, and 20, 25, 20 are the selling price of the products. That's already defined. Okay, this is selling price. Now it's given like 1800 resource units available every day, and the product A requires 20 units while product B requires 12 units. So it's like I can write for resource. Okay, just maybe I'll change the color. I want resources like this one. Resource, I am having 20 for BA, and B requires 12 units. So it is like you can write like, anyway, Y1 products are produced by A. Y1 A products are produced. So Y1 into 20, because each product of A requires 20 units plus 12 into Y2 you can give, and it's like there are 1800 only available. Okay, 1800 only available, so you can give like the total resource available is less than 1800. Okay, now the next thing given is like both of these products required a production time of 4 minutes, and total available working hours are 8 in a day. Okay, so next thing given is like time, you can tell it like time constraint is given. So here if you see, the time constraint is given like 4 minutes and 4 minutes taken for both products. So the time constraint also you can give like 4 into number of products of A produced plus 4 into number of products of B produced should be less than, so that time should be less than the working hours in a day. That means it will be like 8 hours given, no? So 8 into 60 minutes will be there. Okay, so right now, so we have got the objective function, then we have got the resource constraint, and we have again got, so this is like the resource, I'll tell this as the resource constraint and this is the time constraint. Okay, so we have like kind of 3 equations we are having. Okay, Now what I'll do is like I'll do the same thing in the RStudio. Okay, so for that, so I have written this like this here. Now yeah, so you can see here the same thing. Okay, so for this I'll require a new library. Just I will minimize this. Okay, so you can see I have included the library lpsolve. Okay, and objective function I am defining as c of 25 20. Okay, why? Because I had got this one like objective function was maximization of 25y1 plus 20y2. That's why I'll be getting in this RStudio I'm giving objective dot in as c25 20. So objective is stored as 25 and 20. Now we have two types of constraints, the resource constraint and time constraint. So for that I am creating a matrix. First one was 20y1 plus 12y2, that was a resource constraint, and next one was 4y1 plus 4y2, which was a time constraint, and n row equal to 2, by row equal to true. If I am giving that, I am creating a matrix like 2012 with the resource constraint and 4 with the time constraint, right? Now I am naming the time constraint, so it is like 8 into 60 minutes. I have already mentioned it. So time constraint I am storing in a variable time underscore constraint, and resource constraint I am storing in a variable resource underscore constraint, that is 1800. So I am displaying the time constraint, it is like 480 minutes, and resource constraint 1800 okay units. Now what I have to do is I have to set the RHS and direction of the constraint, because it's like a maximization problem. So what I am doing is like just I am defining an RHS right hand side equation like that. I am forming a list with resource constraint and time constraint, right? Because our matrix is like first is defined for resource constraint and then it is defined for time constraint. That's why first I am giving resource constraint and time constraint, and if I give that, RHS is looking like this 1800 and 480. Now I am giving the direction like so. In the problem we had looked like the constraint is given as, so the constraint is given like this is less than or equal to 1800 and less than or equal to 480 minutes. Okay, so because of that I am giving direction as a list of less than or equal to and less than or equal to. So direction you can see less than or equal to, less than or equal to. Then final step, it is to find the optimal solution. So optimum solution I am giving like lpsolve. Okay, we have called lpsolve. So lp of the arguments required in this particular function is, first you have to give what is the problem, what is the type of optimization, whether it's maximization or minimization. So I am giving direction is equal to maximize. Okay, objective dot in will give the what is the objective things like 25y1 plus 20y2, that was the objective, and then constant will give the matrix which has the different other constraints, direction minus less than or equal to, less than or equal to, and RHS 1800 and 480 minutes. So optimum will give that the maximum, this is a maximization problem, so the objective function answer will be 2625, which is the maximum profit obtained, okay, with the constraints which are given. Okay, now if I give, so in this particular option we can see like many different characteristics of that optimum solution also. Just if you want to find the solution means like what are the values of y1 and y2 for maximizing the profit, which is 2625. So the values of y1 and y2 can be obtained like y1 should be 45 and y2 should be 75. That is optimum underscore solution. That means number of product A, 45 number of product A and 75 number of product B should be solved. Now if you give like a summary of optimum, so many other things can be seen. Okay, so like direction, everything. So if you can want to find out, just you have to give the name of that thing where you have stored it, optimum dollar direction. If you give, you can see the direction. Okay, now so just if you give optimum dollar, it will give you, if you give the direction and give that, it will give you like 1. Okay, maximization. Then if you give for the maximum sales figure, you will get the, that is the maximum profit that is to be obtained, which is 2625. So just for more details, if you want to find out for all the variables which are given, if you want to understand what they are, just I have given you a link also where you can go and find that out. Okay, so this is how you will be solving this in an RStudio. Okay, so just I have given the same problem, I have included there. Okay, and with that I think we can stop the session today.